All right, we're going to go through the examples, or I'm sorry, the answers from 11.1, and that's this homework assignment. And then we're going to go through yesterday's answers from 11.2, and then we'll talk about the quiz tomorrow. All right, so number 1, function or not? Yes. Number 2? No. You could have a fail point of 0, 1, 2. What about 3? Is 3 a fail point? Why? Yes, because the circles are closed. Number 3, function or no? Yes. Good. Number 4? No. As a fail point, you could have had -2, -1, 0, 1, 2, or 3. Okay, it fails along all of those x values. How about number 5? Nope. Where's it fail? At 4. Good. X at 4 is where it fails because it turns and starts heading straight up. Okay. Number 6, function or no? No. Your fail point could have been -3, -2, -1, 0, 1, 2, or 3. Okay, it fails at all of those places. Number 7, yes or no? Yes. Good. Number 8? No. Good. And it fails at -3, -2, -1, 0, 1, 2, possibly 3. But since you have other good ones to choose from, it depends on how well and how big you make the picture and how much you think that circle comes to a point right at 3. So if it were me, I would avoid using that point just because it's iffy as the fail point, but you have so many other options that you don't need it. All right, how about number 9? Yes, it is a function. It does pass the vertical line test. All right, number 10 is a function. Number 11 is not a function, and you could have had x equals 2 or x equals 4 as the fail point. Number 12 is a function. Number 13 is a function. Number 14 is a function. 15 is not a function because of x equals -4. That's that repeating x. Number 16 is a function. Number 17 is not a function because of x equals 3, repeating. Number 18 is a function. Number 19 is definitely not a function, right? That 0, x at 0 is definitely an offender there. Number 20 is a function, and number 21 is not a function because of x equals 9. All right. Addison or Tyler, I'm going to hand you this. If everybody would just day 1, pass day 1 over, please. If everybody would pass them to Will. Will, on Tyler's, there is a paper clip. If you'll paper everybody's together and put it under the tray because they're already graded. Okay? Thank you for keeping the paper clip one on top. I appreciate that. Very nice. And then they can go under because I've already graded them. All right. Next, we're going to look at 11.2. And this one the first half will be fast, but the bottom half we're going to go slower through. All right. Thank you, Will. All right, number 1. Yes, it is a function. None of those x's are cheating x's, right? Number 2 is a function. Number 3 is not a function, and it's because of x equals 4. Okay, that's your cheating x there. Number 4 is a function. Number 5 is not a function because of x equals 5. And number 6 is not a function because of x equals 3. Okay, number 7 is a function. There's no repeating x's. Number 8 is not a function because of x equals 6. There's 2 of those in there. Number 9, it's kind of squeezed in there. I've missed it twice today when I've gone through this worksheet. Number 9, if you listened to the video, you heard me say that any linear equation with a slope. So what's our slope in number 9? 2. Any linear equation with a slope is always going to be a function because a straight line running diagonal will forever and ever pass the vertical line test. So you don't have to graph this if you know that knowledge and can remember it. If you don't know that and you don't remember it and you're just given an equation, graph it and then see if it passes the vertical line test. Same thing with number 10. If you remembered the information I gave you Y's, do they always or do they never pass? Always. Y's always pass. The reason is because they're horizontal, and so they always will pass that vertical line test. They don't ever loop back around over themselves. X's, will they always or never? X's never pass the vertical line test because they are in themselves a vertical line. So if you were to have something like x equals 2, it would fail at x equals 2 because x equals 2 is a vertical line. Okay? So number 9, yes. Number 10, yes. Number 11, yes. That's another linear equation with a slope, so that's always going to pass. Number 12, remember I said in the video, if there's just dots, don't connect them because you don't know what order to connect them, so you can't assume. So you just leave them unconnected and you simply state whether or not the dots are a function. So the way you do that is you look and you use the vertical line test, and right, it passes because there's only one point on that one. It passes, but there, boom, it does not pass because 2 points are on that one line. So that would be a no, and it would be because of x equals 2. Okay. Number 13, is it a function or no? What do you guys think? No. And you have a couple of options here. You could have 1, 2, 3, 4, anything up in there as the offending x. Pick one, anyone. I wouldn't pick 0 just because depending on how close your point is. So since you have other good ones to choose from. All right, this is where we're going to slow down a little bit. And we are going to actually work all of these. So, and I actually, after I did the video and I was actually sitting at home last night, one of my students had a question about one of these. And so I was working on my iPad and then screenshotting it and sending it to him. And when I did it a little different, and I thought, I like that better. So I'm going to work the examples that way today. It's not really a change. It's just writing something out that kind of helps you connect it. So, all right. So we have 2 functions here. We have an f function and a g function. Remember, there's nothing special about f and g. You could use h, p, element of q. It doesn't matter. But it's just its name. So the f function is 2x minus 5, and the g function is x squared plus 4x. So for number 14, this right here tells me I'm going to use the f function, okay? And if I use the f function, I'm just going to write out right here, this is the f function, 2x minus 5. So f of 4 equals 2x minus 5, and you're asked to evaluate that. Well, you evaluate it by putting parentheses around the x, and there's already parentheses around the 4. And so you're going to rewrite this by plugging the 4 in anywhere where you see an x. And then you're going to use PEMDAS to evaluate it. PEMDAS says parentheses first. So 2 times 4 is 8, minus 5 equals 3. So the answer is 3. If you just square 3, I'm fine with that. Technically, the way you should write out your answer is that f of 4 equals 3. And what that means is the function plugging in a 4 equals 3. The f function, I should say. The f function, when you plug in a 4, you get 3. That's the output. Okay. All right. For number 15, it's also the f function. So again, and this is what I didn't do in the video, and when I do it for next year, I'll probably do it a little bit differently, is since I see f right here, I'm just going to write this right here every time, 2x minus 5, because that is my f function. Now I'm going to go in, put brackets around the x. There's already brackets around the 8. The 8 is my input or my ingredients that I plug into my function. So I have 2. I'm going to plug in that 8 where there was an x, minus 5. 2 times 8 is 16 minus 5. 16 minus 5 is 11. So f of 8 equals 11. Or the f function, when you plug in an 8 as input, gives you the output of 11. Okay? Any question there? All right, next we will do number 16. And thank you so much. Look at that. Boom. Oh, that's just the bomb. Okay. Thank you, Addison. Number 16, f of negative 2. Again, right? The f tells me I'm going to use 2x minus 5 because that's the f function. So I'm going to write 2x minus 5 again. Now I'm going to look at my input or my ingredients, and they are negative 2. So 2 times negative 2 minus 5. I just plug in negative 2 into my function. And something that, if you'll guys notice, I do it. It's just kind of a lazy thing, but I am totally good with being lazy. You'll notice that I don't ever keep writing off to the left that f of negative 2, f of negative 2, f of negative 2. It's because once I write the equal sign, I'm only working on the right side of the equation. I'm not moving anything over. There's nothing over there to evaluate. Remember, it's just a fancy y. So you don't do anything with it. You leave it over there by itself, and it stays over there, and you don't evaluate it. You don't distribute. You don't move anything over there with it. It just stays over there as a y. Okay, so f of negative 2, we plugged a negative 2 in. 2 times negative 2 is negative 4 minus 5 equals negative 9. So f of negative 2 is negative 9. Now with number 17, we see the g function for the first time, right? There's our g. Well, here's our g function right here. So I'm going to write x squared plus 4x. That's my g function. Now I'm going to, put brackets around every time I see an x. And I'm going to put brackets around the 2. And now I'm going to plug in everywhere where there was an x. Always keep your brackets. Okay, they do matter. I'm going to plug a 2 in everywhere where there was an x. 2 squared is 4. And then positive 4 times positive 2 is positive 8, which equals 12. Any question there? Oh, I thought you had a question. You were just stretching. All right. You just saved me so much time. Number 18, again, right? It's the g function. So I'm going to go over here to my g function, which is x squared plus 4x. That's my g function. Now I'm going to put brackets around every time I see an x, and I'm going to put brackets around that input. So I get negative 3. Brackets are important. Okay, if you don't use your brackets, your signs will be messed up here. Plus 4 times negative 3. Negative 3 squared. It does not mean negative 3 times 2. I've had a couple people do that today as a refresher, right? Squared means negative 3 times negative 3, which is positive 9. Positive 4 times negative 3 is negative 12, which equals negative 3. So g of negative 3 equals negative 3. On number 19, again, it's the g function, so I'm going to use x squared plus 4x because that's the g function. I'm going to put a bracket around every x, and I'm going to put a bracket around the input that they give me that is 4x. So now I've got bracket, negative 6 in that bracket, negative 6 in that bracket. Marcus, get your head up, please. All right, negative 6 times negative 6 is positive 36. Oh, I put an equal sign. Or I put 2 minus signs. I'm not quite sure what I was doing there. I was thinking and talking at the same time. There we go. All right. Positive 4 times negative 6 is negative 24. 36 minus 24 is 12. Okay, any questions on that one? All right, number 20. This is the first one where we have that example of a function plus something, right? Plus that little dangler of plus 1 out to the side. So first of all, we need to use the f function. What was our f function? 2x minus 5. All right, so 2x minus 5, that's my function. So I still do it the same way that I did before, which is a bracket around my x and a bracket around my input. 2, bracket, my input is a 2, minus 5. That's the function part of it, but you still have to go back and add on at the end, tack on that plus 1 at the end. So it's a function plus 1. So here's my function, and then, that was weird, and then my plus 1. Okay? Function plus 1, function plus 1. All right, so now we still do PEMDAS. And PEMDAS says 2 times 2 is 4 minus 5 plus 1. 4 minus 5 is negative 1. Negative 1 plus 1 is 0. So f of 2 plus 1 is 0. Okay, we're using our f function again here. So I'm always going to start out by writing my function. then I'm going to put brackets around my x and brackets around my input. So I have 2. My input is 1 minus 5. That takes care of the function part. Then I have to go back. There's my plus 1, kind of that add-on at the end, or that subtraction at the end. Minus 1, so I'm going to tag that on at the end of my function. Okay, using PEMDAS, I'm going to do multiplication first. 2 times 1 is 2. Minus 5 minus 1. And then I just have a string of addition and subtraction. So 2 minus 5 is negative 3. Minus 1 is negative 4. So f of 1 minus 1 is negative 4. Are we good there? Okay, if I need to slow down or if you guys have any questions, please don't hesitate to holler. All right, number 22. G of 2 minus 2. So our function of 2 minus 2. So our G function is x squared plus 4x. All right, that's my G function. Brackets around the x, brackets around the input. So I'm going to put in that 2 everywhere where there was an x. And I've got this little scraggler out to the side that I'm going to stick out to the side. All right, PEMDAS says parentheses and exponents. So 2 squared is 4. 4 times 2 is 8. And then my little scraggler of minus 2. 4 plus 8 is 12. Minus 2 is 10. All right. What's my G function? X squared plus 4x. All right. This says I'm using my G function, so I've got x squared plus 4x because that's my G function. Brackets around the x, brackets around my input. So I've got negative 1 in my input, oops, squared, plus 4 times negative 1. And then what I don't want to forget is that plus 4. And if you're afraid you're going to forget it, even in that first line when you write out your function, you could even put that plus 4 there. As long as you tack it on to the end and you do it last, it doesn't matter. Just don't forget it. All right, negative 1 times negative 1 is positive 1. 4 times negative 1 is negative 4, and then plus 4. And then plus 4 and minus 4 cancel out, and you're left with 1. Okay, we good there? All right, last one. Is when you have a binomial as your input, right? So because both things, that x plus 1, because they are both inside the parentheses, that means both of those are part of your input. That's not a scraggler one. It's actually in the parentheses. So first thing is first is it tells us f function. So we're going to start with our f function, which is 2x minus 5. Okay, that's our f function. We're going to put brackets around the x. And brackets that are already there, that whole thing is my input. So my 2 is part of my function, my bracket. Now in place of x, I'm going to put the whole input that is in parentheses, which is x plus 1. And then minus 5, because that's the rest of my function. And then I have to distribute. So 2 times x is 2x. 2 times 1 is 2, minus 5. And now it's just a matter of combining like terms, okay? So 2x is the only x over there, so I cannot combine it with anything else. It stays there. Plus 2 and minus 5 is minus 3. And so this would be your final answer. And I do want to point out something, and this is a good example because it was at the bottom here, and so you could really see it. Notice I don't put anything over here. And the reason I don't put anything over there is because I'm lazy. Because what I would have to put over here every time is this whole... right? This whole thing. And because I'm lazy, I don't want to write that a bunch of times. So I just leave it blank, and that's just the assumption. That's the assumption that that name, right, or that title, or that function information just drops down with me. And so on my final one, if I really wanted to get technical, I could write it again. But I just leave it blank, and that just denotes, and remember I said it's just like a fancy Y? So, you know, you wouldn't ever write it like this, but it's the same as if you just kept saying y equals y equals y equals. Okay? But again, you wouldn't want to write y there because it's a function, so it's not just y, but it works as a fancy y. Okay, any questions with those? All right, remember, you do not do anything on the left side of the equal sign. That's just where your name stays, and you do not change it. You don't move anything over there with it. You don't distribute. I've had people try to distribute that f and make f of x and f plus 1 and lots of crazy things. Don't do anything on the left side of the equation. Plug in and do all your evaluating on the right side of the equation, and then your answer stays on the right. Okay? All right, tomorrow is the Indicator 11 quiz. And I do have the review. If you're at home or you weren't in class today, the review is on Kami. If you were in class, you have a paper copy of it. We will go over the review after we grade it. I'll check for a grade tomorrow, make sure you have it done. Then we'll go over the answers, and then we'll take the Indicator 11 quiz for tomorrow. Okay?